Without further ado, I'd like to introduce our first speaker for tonight. It is Dr. Margret Leinen, who, as I mentioned, is the president of AGU and director of the Scripps Institution of Oceanography. Prior to joining Scripps, she served in a variety of academic leadership positions, such as Vice Provost for Marine and Environmental Initiatives and Executive Director of Harbor Branch Oceanographic Institute, as well as Vice Provost for Marine and Environmental Programs and Dean of the Graduate School of Oceanography at the University of Rhode Island. She also served as Assistant Director for Geosciences and Coordinator of Environmental Research and Education at NSF. She is also a past president of TOSS and has served on a variety of academic research councils, steering committees, and boards of directors, including the Research Board of the Gulf of Mexico Research Initiative. In addition to these leadership roles, Margaret is a researcher in paleoceanography and paleoclimatology. Her work focuses on marine sediments and their relationship to global biogeochemical cycles, and their role in unraveling the history of Earth's ocean and climate change. She has a broad perspective on future challenges posed by climate change and on potential mitigation strategies. Finally, she is a fellow of the American Association for the Advancement of Science and a fellow of the Geological Society of America. We are honored to have her with us tonight. Please join me in welcoming Margaret to the stage.
Thank you. I'm sorry that Jane isn't here too. I was looking forward to hearing from her. When they called on Friday, they said, could I talk to you for 5 or 10 minutes on why ocean sciences was important? And now that would really be taking coals to Newcastle. I think you know why ocean sciences are important. What I'm going to do instead is tell you about a few very important other groups that are starting to get the message about ocean science and that make me very optimistic about people starting to understand what we know about the role of the ocean. So the first of these is the UN. Most of you know that about a decade ago, the UN actually more than a decade ago, they developed the Millennium Development Goals. Very important goals that had to do with eradicating poverty, dealing with inequity, the role of women, and so forth. Those were followed more recently by the Sustainable Development Goals. And, well, I should also say the Millennium Development Goals had little to say about the environment and nothing to say about the ocean. But here, among the Sustainable Development Goals, are Goal 13 on climate action, Goal 14 on life before water. And each of these really has its roots in this community. The goal on climate is to take urgent action to combat climate change and its impacts. And of course, this community has had a major role in talking about the role of the ocean and also talking about the impacts of climate change on the ocean. And then Goal 14 is to conserve and sustainably use the oceans, seas, and marine resources for sustainable development. And this, too, is an area where this community, with its focus on understanding the biological systems in the ocean, understanding the role that we play in the ocean and its sustainability, will be critical for setting the agenda. So in a place where ocean sciences had not been before, it is now. And speaking of climate, the recent Paris Agreement has, for the first time, a focus on oceans as well. So for 20 years, we've had the Conference of the Parties, and we've had a lot of attention to climate, but never a realization that the oceans play an important role. And for the first time, we have language. It only appears once, but that's all it takes for us to start talking in the climate negotiations about the impact of climate change on the ocean, the role of the oceans in climate change, and not just warming of the oceans and ocean acidification, but also oxygenation, as you're going to hear from Lisa Levin later. A third group that has recently started focusing on the oceans is the Group on Earth Observations, GEO. So this is an international group that coordinates the many observing systems and really promotes the interoperability of data between and among them. They have a number of flagship activities, but they'd never had one that was focused on the ocean. But in response to the call from our community, a new initiative is present in the Group on Earth Observations, the Blue Planet Oceans and Society Initiative. And this recognizes everything that this community has done, and this isn't just physical observations, but all observations of the ocean. And in last year's G7 talks, we saw even more activity as marine debris and the deep ocean, conservation of the deep ocean, and deep ocean mining became part of the G7 negotiations. That's a long way to come in a decade when previously we weren't even at the table with development goals, with the UN, with the Group on Earth Observations, and so forth. And I think it's a real positive signal for us that just as we know how important it is, that the rest of the world is getting the message too. Thanks very much.
Thank you very much, Margaret. So it is my pleasure now to introduce Professor Jim Elser. Jim is president of ASLO and director of the Flathead Lake Biological Station at the University of Montana, with a joint appointment as a research professor in the School of Life Sciences at Arizona State University. Jim serves as a lead investigator for an NSF Research Coordination Network on phosphorus sustainability and is a fellow of the American Association for the Advancement of Science. He's also earned several awards for teaching excellence and innovation, in addition to the G. Evelyn Hutchinson Award and the Lindemann Award, both awarded by ASLO. Jim's research area in the area of biogeochemistry, ecology, and evolution seeks to understand how the stoichiometry and coupling of carbon, nitrogen, and phosphorus shapes the ecology and evolution of living things. To do so, they work with a variety of ecosystems, biota, and approaches that highlight the interdisciplinary nature of marine and aquatic science. He has a broad perspective on the importance of research in these areas, and we are honored to have him with us tonight. Please join me in welcoming Jim to the stage.
Thank you. Well, hello everyone, and welcome to New Orleans, and thanks for coming to this incredible meeting. It's going to be an amazing week. So, yeah, I'm a limnologist, but this is my third ocean sciences meeting, and I enjoy them tremendously. I've done a little bit of oceanography. I've been to sea a couple of times. If you see Walker Smith, he can verify that. He may not verify how much work I did on that cruise, but I was aboard. So it's really, really exciting to be here, and I just want to talk a little bit about my thoughts about lakes and oceans, limnology and oceanography in the context of this meeting and the things that we all have to learn from each other and how we think about water and how important it is. So when I think about oceanography, my biggest scientific hero, of course, is A.C. Redfield, and there he is in his dapper tie. I wish I had one of those to sport today. And when I think about oceans, I think about their size. And oceanographic thinking tends to be big, and it tends to be very synthetic and systems level, and very challenging in that regard. And I also learned from my time at sea that oceanographers learn a lot just by driving around. They drive their boats around and measure stuff, and they use the natural play of the Earth's system as experiments to understand the oceans. And that is a really cool way to do things, and so I learned a lot from that perspective. And I do want to call attention to, and congratulations to Barry, Neville, and Cher winning this year's Redfield Award from ASLO for Lifetime Achievement. So that's oceanographic thinking, and certainly everyone here thinks big and is very synthetic thinkers. So what about limnologists? Well, here's my one of my other scientific heroes, G. Evelyn Hutchinson. Perhaps a little smaller in scale, perhaps thinking more mechanistically about things, and I think that's true when we think about G. Evelyn Hutchinson and how he reasoned from first principles toward a lot of deep insights into life in water. And the other thing about limnologists is that we have opportunities to do direct experimentation as a main tool of investigation, and that's at all scales, right, from chemostats through mesocosms through whole lakes, right? And so I think in that sense the limnological approach is a little bit different, but certainly informs the insights that we get from studying inland waters. So how does oceanographic and limnological thinking relate to each other? I think, of course, one of the goals of ASLO is to encourage that cross-dissemination of insight and powerful approaches across the whole gradient of the aquatic sciences. And here's A.C. Redfield again in a less-known picture. He's pointing at something. And I don't know if any of you know what he's pointing at. He's pointing at Lake Superior. He's pointing at a lake. So yeah, there is a lot of insight oceanographers will gain from learning more about lakes and vice versa, and I certainly have benefit a lot from the oceanographic work that is out there. So here's an example perhaps of the kind of things that we can learn about the functioning of ecosystems. Here's a stoichiometric histograms of organic matter production in terrestrial ecosystems and in lakes. And you can see that there's a tremendous gradient of stoichiometry of organic matter formation that's possible. Especially look at the bottom there, the broad distribution that we see in ceston in lakes with an average of about 30 to 1. Now, if we were to put the graph for marine organic matter on there, it would cluster very closely around Redfield's famous ratio of 16 to 1. And that tight clustering has sometimes led oceanographers to think of the Redfield ratio as if it's a physical constant like the speed of light in a vacuum. But what we know from lakes is that that's not the way that life has to be. We know from experiments and other insights that organic matter can be formed at all kinds of ratios, and so that 16 to 1 ratio has a certain and very significant meaning that we need to gain more insight into. This is really important in the current understanding of the coupling of large-scale oceanographic systems. Here's a classic diagram from Dave Carl's group where they coupled the physical functioning of ecosystems driven by various sorts of changes driven by climate change to their consequences at the larger scale. And at least two of the major mechanisms that propagate climate change impacts on the sea to the biogeochemical feedback are mediated by stoichiometric mechanisms having to do with the stoichiometry of organic matter formation and the net balance of N fixation over denitrification. So this is pretty cool. I think it's I know I've learned a lot about lakes by thinking along this way, and I'm still in dialogue with a lot of oceanographers about it. And in fact, in a shameless promotion, I encourage you to come to our session on Friday morning where we're examining life beyond Redfield, and a lot of great talks are lined up along those lines. All right, so just a couple more thoughts about water thinking as we go into the rest of the week. We've heard discussion about climate change already, and certainly that's on many of our minds. One thing I worry about, especially in the aftermath of the Paris meetings and agreement, to have a focus on a 2 to 4 degree change in average annual temperature of the Earth. Now, if I was a person who wasn't a biogeochemist or ecologist or scientist and heard 3 degree temperature change, I wouldn't worry too much. Now, we know that the direct effects even of a 3 degree change can be pretty important for metabolism and chemical reactions and such, but I think we also know that there's not more to it than that. And if the main message about climate change that might get out is about an average change of about 3 degrees centigrade, we shouldn't be surprised that people might not be too concerned. And so what we have here is a failure to communicate, if that's the message that people are taking away. And certainly there's a lot of great communication going on already, and people are doing a terrific job, but there's so much more we can do. And basically, what I think we really need to communicate is that climate change is water change. the biggest things that we are concerned about in climate change are almost all of them mediated by changes that are going to take place in water, whether those be the large-scale changes in the circulation of the ocean, the operation of different biogeochemical pumps, changes in precipitation, etc., all of which, of course, all of you know all about and are deeply involved in studying. As a limnologist, climate change for us means hydrologic change. It's a change in the water cycle. It's the appearance of streams and lakes in places where they weren't before when glaciers melt. It's the disappearance of streams and lakes and wetlands in places that they've always been because of drought or changing runoff patterns. So for us as aquatic scientists, we are really, no matter what we're doing, we're studying climate change because climate change is being felt and propagated most strongly in all of our aquatic ecosystems. So what do we have to do this week and forever, right? Until we pass from this earth. Well, this week on the fun side, right? We're going to be sharing our ideas with each other. So to share our data and to sharpen our science, we have to be really, really good at what we do because what we do is so important. And part of what we do here is share our science to get feedback in a positive way, right? But we have to be very, very good. And that's one of our goals this week is to sharpen our science so it gets better and better over time. And of course, what we have to do is share our science with everyone so that we can maintain the trust of those who listen to us and we can advance understanding that allows us to make better and informed decisions about our shared future. So with that, I just want to thank you all again for coming. I look forward to seeing you, many of you around during the week, and welcome to New Orleans.